Mathman Price here for Pi Day activities. What can you do on Pi Day every year, March 14th? Where do we start? I've got some activities for you, give you some ideas. Where do you start? Start with a circle. What's the definition of pi, or where do we first come across it? Well, you can have your students take circles, all kinds of different ones, measure the distance around, string, yarn, works fine, measure the distance across, divide them out. The farther, the better you do, you'll get pi, 3.14 approximately. I got some slides here for you on this overhead. Sorry for the inconvenience, but we'll go with activities. Here's one of the better ones. A large rope is tied snugly around the equator, a total length of 22,000 miles. The rope is cut and a 3-foot section is added. The rope is then evenly redistributed. How far off the ground would the rope be now? Great problem. A rope, rubber band, a string around the earth. Equally, I mean, forget about the equator, forget about the oceans, the mountains, okay. You cut it, 22,000 miles of rope. You cut it, you add 3 feet, 3 feet. Then you redistribute it. You can draw a picture like this and redistribute it. How far off the ground will it be? Amazing thing is, it's going to turn out to be about 6 inches, no matter how big a circle is. You take a quarter, you add 3 feet onto the circumference of it, redistribute it around. It won't matter if it's even the sun. You take a rope around the sun, you won't get burned if you go at night, by the way. If you do that and redistribute, it'll be about 6 inches. You can prove it with algebra that it'll be the same no matter what size circle. Next one, related to that. If a 6-foot tall person walked around the earth 22,000 miles, how much farther would his head or her head be rather than be his feet? Going all the way around the earth, walking those 22,000 miles. This would be the next day's activity if you want, maybe. How much farther is your head going to go than your feet? And you might think, well, that's not going to be very far. Turns out that it's quite far. Use your algebra, use your skills about circumference and diameter. Okay? Next problem. Related to pi. Classic problem. If a man and a half can eat a pie and a half in a minute and a half, how many men would it take to eat 60 pies in 30 minutes? One of those, like triple ratios. Man and a half, eat a pie and a half in a minute and a half. You can tie that in with eating pie if you want. Figure it out. Great problem to solve. Next slide. What would give you the most orange juice? 3 oranges with 1-inch diameter, or 1 orange with 3-inch diameters. 3 oranges with 1-inch diameter versus 1 orange with a 3-inch diameter. Have them calculate that with 3D volume. Next slide. How can you cut a 2-layer round cake? That's where the pie comes in. How can you cut a 2-layer round cake into 8 equal pieces using only 3 cuts? 3 cuts. 1, 2, that makes 4 good pieces. I want equal pieces, 8 pieces using only 3 cuts. 1, 2, 3. Make 6. Let's see. Answer: 1, 2, 3. Next problem. Tennis balls are packed tightly in with 3 in a can. If the can, is the can taller than the distance around the can, or is the reverse true? Got an example here right for you. Taller versus around. Which one is it? What's your logical intuition say? It's taller. Take a string, go around, measure it, drop it. Turns out it's a little bit longer by the distance around. Why is that? 3.14 times diameter versus 3 times diameter. Easy, but simple. Okay? Next problem. Where does pi pop up? Turns out that pi is not just circles. Not just circles. It's also used in other kinds of things, interestingly enough. Here's one example. You can get a good approximation for pi by doing this infinite series. 4 over 1 minus 4 over 3 plus 4 over 5 minus 4 over 7 plus 4 over 9, etc. You keep going. The farther you go out, you get closer and closer to pi. Why is that? Look on the internet. Good series. Next slide. Euler's identity. Where does pi pop up? Where does this act? Amazingly enough, you can go through the math. This is high level, pre-cal or above. E to the pi I plus 1 equals 0. Here's the 5. Five incredible numbers. 0, 1. You can talk a whole lot about a lot of things with just 0 and 1. 1 on and off. Base 2, logarithms, probability, stuff like that. Euler's constant. Pi, of course. Oh, that just comes from circles. There's other places. And then, of course, imaginary numbers. We got 3 of these incredible numbers plus 1 equals 0. All right? Here's another problem you can do for the students. Which one has more volume? Regular sheet of paper, 8.5 by 11. Make a cylinder this way. Fill it full. Or take the same piece of paper. Tape these together. Fill it full. Which one has more volume? Well, maybe they're equal. You check it out. Got an activity that you might want to do in algebra class. Take balloons. Take 2 people, 1 balloon. 1 puff, blow up the balloon. Measure the circumference, measure the diameter. Take another puff. Measure the circumference, measure the diameter. Graph those. Guess what? If you graph the circumference versus the diameter, you're going to get an equation, slope-intercept form, y equals 3.14 pi, or times the y, the x. You could prove, by the way, if I had time, you could prove how to get the area of a circle. Area of a circle you can do with triangles. Y is pi times r squared, area of a circle. Here's one way. Infinite number of triangles. Let's say this is a base of r. Well, better not use that. Let's take r as a radius. Let's see. Then the basic, if you got smaller and smaller, you'd have a triangle that would have a height of r and a base. The base is all the way around. The base is all the way around. How do you find the area of a triangle? Half times base times height. Half base times height. Well, what's the height? R. What's all of them put together? Circumference, pi times diameter. Otherwise known as 2 pi r. Cancel out the halves, you get pi r squared. Area, how does the area of a cylinder or a circle come about? Let's see. I think Village Inn should do a special national thing with pies to get pies for a cheaper price into the classrooms on Pi Day, but that's a different story. You can look up a mathematical pi song on YouTube. You can have a pi recitation contest, see who can do the most digits of pi. You can have pie in the face for math department. Take people who, like me, take a pie in the face and raffle off tickets, and the kids would love to do that. Come down and put a pie in your face for a price, of course. One more. Squares and circles. Perimeter of the square that's circumscribed around the circle. Well, if this is r, this would be 2r, so we get a total of 8r. What's the circumference of the circle? 2 pi r, so it would be 2r, let's see, 2r, 8r, pi times diameter. The diameter is 2r. You get what? No, that's not right. Skip that part. Let's take area. If this is r, this is 2r, that would be 4r squared for the area. Circle's area would be pi r squared. The ratio of the circumference to the perimeter is pi over 4. The ratio of the area of the circle to the square is actually pi over 4. Check it out. Sorry for the mistakes. There's one more slide I got here. It says, an opinion without 3.14 is just an onion. An opinion without 3.14 is just an onion. Have fun on Pi Day.